or a pen, and let's go to town. Okay, so right from the get-go, we're told that the gestation period, length of pregnancy of hippos, right, this particular species has a mean of 200, right, and a standard deviation of 3.5. Okay, and so that's a given for the rest of this page, right? So if you want to know the percentage or the proportion or the probability, don't let that throw you off, right? We all mean the same thing, right? Where something, a pregnancy would last more than 204 days, right? More than 204 days. That would be normal CDF, right? So we have, let me put my key in front here. Normal CDF. And I need you to show me the entries. So 204, and then 10,000 perhaps, or 100,000. 200 would be the mean, and 3.5 is the standard deviation multiplied up by 100, right? And if you cut to the chase, that many pregnancies would be considered. So I'm not going to show you how I enter this. I'm just going to show you what the entries should have been. Okay. Anybody got a slightly different answer? Sometimes in certain instances when you go like a million or something, this might be a little bit different, but most of the time it shouldn't affect. Just pick a big number, right? 1 mark for that. Only 10% of, oh, and yeah, 204 puts you right about, like if you go up by the standard deviation, 204 is right about there, right? And so if you consider this and up, does make sense that we have 12.65%, right? Only 10% of hippo pregnancies last less than so many days, right? So the 10% last less. So that puts you somewhere in a position where you have 10% of pregnancy that would last less than this value you're interested in. In this case, it would be days, right? I always talk about score, right? It's not, in this case, it's number of days. So we're going to figure that out. So inverse norm it is, right? Inverse norm 0.1, 100, no, sorry, 200, sorry, 200, 3.5, okay? And this number, this is, whatever you get here is going to have the same units as your mean and standard deviation, right? And you get 195.51 days, okay? That is your answer there. Next, only 20% of hippo pregnancies last longer than X number of days, right? 20%, right? So percentages given, most likely inverse norm, last longer than this. So basically you're saying I'm somewhere here where 20% of pregnancies would last longer than X number of days, right? You want, I already did 2080 earlier, didn't I? Anyways, it's okay. You needed to know, so this gives you a mark. If I go to inverse norm, if you put in 0.2 here, you're going to lose a mark, right? It's supposed to be 0.8, 200, 3.5. And that is 202.95 days. Okay, so you get a mark for that, figuring out the 80%, and a mark for your correct final answer. So you still get 1 out of 2 if you used inverse norm. Okay, so there we go. This one I'll make a bonus. I don't know if you were able to do this one, but the middle 70% of hippo pregnancies last between this and this many days. So the middle 70, I want you to think of, right, 70% in the middle. So let's think about this. If you have 100% under the whole curve, right, and you split you take the 70 away, right, you're left with 30%, right? And because we were told it's in the middle, that means that this will be 15% and this will be 15%. So let's see if you can follow this. I'm going to call this X. I'm going to call this Y. I will figure out X first, right? X will be inverse norm. What's the percentage below the value I'm interested in? Because inverse norm needs below, doesn't care about above. But in this case, it would be 15%, right? So we'll figure out X. And then for Y, this one is trickier. But let's see. For Y, what percentage is below Y? The answer is 70 and another 15, correct? 85%? I hope that makes sense. Oh, sorry. I'm going to put Y equals underneath. So this allows you to figure out the 2 days that we're interested in, right? The pregnancies, right? In terms of days. And so for the first one, you get 196.37 days. And for Y, you're getting 203.63 days. I would say this is a +2 if you got this right. So we'll make this a bonus question. So I used inverse norm twice. I used it once, knowing that we had, for this first value, we had 50% to the left. For the second value, we had 85% to the left. And it all started with this, right? That we were given the middle 70. And so we figured out the 15, 15. This 15 was never really used, right? But it still helped us to figure out this one, right? Because we took the 30 and split it evenly there. So that means that this page is only worth 4 plus the bonus, right? So you can potentially score 6 out of 4 if you got the bonus right here. Backside. Calculate the z-score for a 21 millimeter frog. Explain what this means. Can you use inverse norm like I did earlier? Do you know the percentage to the left? You don't, right? So you're stuck. In this case, you're stuck with the formula. So this is 21 minus 20 divided by the standard deviation is 0.7. And that is 1 over 0.7, which gives you 1.43. This is worth 1 mark, this question. I didn't put it on the back side here. And then just think about it this way. This is 20. This would be 20.7, right? So standard z-score of 0, z-score of 1. This one would have a z-score of 2, right? So if you add another to this one, that would be 21.4. If you go up by 0.7 at a time, 21 is right about here. So it makes sense, right, that it's 1.43 positive. So it tells you that a frog with this length is 1.43 standard deviations above the mean. Okay, a frog with a length, length of 21 millimeters is 1.43 standard deviations above the mean. Okay, so that it tells us both, like the z-score is just a number, but what does it tell us is the number of standard deviations above or below the mean you would be located on the curve. Okay. Okay, next, B, a different dart frog is this long. What percentage of frogs would we expect to be shorter? What percentage? That's the key word. That tells you that normal CDF is required in this case. So you want shorter, which means we're going to go negative 10,000 because our value is in the tens, right? If our value would be in the thousands or the hundreds of thousands, then just adjust accordingly. Like just go big or go home, right? Kind of thing. And so we've got 20 and 0.7, and we're going to multiply that by 100, and we get 74.9% of frogs. One mark. Yeah, so far everything is 1 mark on this page, okay? So A is 1, B is 1. C, what percentage of frogs are shorter than this or longer than that? In math, and you'll see this in grade 12 applied, especially when we do probability, when something is or, we add. Right? This or that, you want to add the probabilities of both the results. This is going to be worth, okay. I'm not at, I hope you're okay with just one method. I think I will make this worth 2, okay? So I will do this. Watch what I'm going to do here. I'm going to figure out, I'm going to go normal CDF. I'm going to figure out the percentage between, don't erase if you did it a different way. Do not erase yet. Okay. What is it that I'm doing here? I'm figuring out the percentage. Let's say this is 21.1, this is 22.2, right? I'm figuring out the percentage that is actually between here and here. That's my first step. Okay. And that gives me, without turning it into a percentage just yet, I get this. Okay. Percentage between values. But I really want this. I want longer than this, and I want this. This is really what I want, right? So how can I use this to figure out the little slivers on the outside? Do you remember what the whole curve is? It's 100% or 1. So I'm going to go 1 minus 0.4424 is 0.5576 or 55.76%. And so this is what I'm after. So if you did it this way, you get 1 mark for figuring out that, 1 mark for figuring out this. But I will tell you another way of doing this is figuring out just this on its own, then figuring out just this on its own. So 2 normal CDFs required, and then just add them up. Okay. Let me do that down here. Normal CDF, negative 10,000 to 20.1, and that's 21, 0.7, plus, this figures out the little sliver here, plus normal CDF, 22.2, all the way to 10,000. I'm going to go up 10,000. So from here above, I'm going to figure out the percentage there, which is 21, 0.7. You still get 55.76%. Sorry about that. It didn't really leave you a whole lot of room to do both methods. I didn't require 2 methods, but I'm just letting you know there are 2 ways of doing it. So if you see the opportunity, seize it, right? It's faster. And the bell is about to go. How much time? Oh, it's gonna go any minute now. Just keep it, bring it back tomorrow. I still want to finish marking this, and I'm just gonna do the honor system. You're not gonna cheat or add anything. Homework will be posted, okay? It's 2 pages in the booklet. Please do it, okay?